At the SIU School of Medicine in Springfield, healthcare leaders are conducting groundbreaking research that is having a positive impact on communities across the country. Inside Dr. Ben Richardson's lab, he and his team are studying neurodevelopmental disorders. More specifically, they're looking at genetic and environmental risk factors in hopes of developing new options for the treatment of disorders such as autism, addiction, and depression. Much of the resources in his lab are dedicated to studying the brain and behavior. SIU Foundation Chief Operating Officer Jeff Gleam heads into the lab with Dr. Richardson to observe his research in real time and discover how his work could lead to new treatments in the future.
We're here at the capital city of Springfield, Illinois, at SIU's medical campus. And with me is Dr. Ben Richardson. So Ben, tell our audience a little bit about who you are and what you do here.
So I run the Neurocircuits lab here at SIU School of Medicine on the Springfield campus, and we try to look inside the brain and understand a little bit about what's happening in the context of neuropsychiatric and neurodevelopmental disorders.
I think we're going to go take a tour of the facilities.
We'll see the lab, see some students in action.
Okay, we're just not going to take a look at my brain though, right?
Only if you really want to.
Okay.
Yeah, so we're on the third floor of our research building here at SIU School of Medicine. What we focus on is trying to understand how certain risk factors that are associated with disorders like neuropsychiatric disorders and especially neurodevelopmental disorders, we want to know what these risk factors do to the brain to then shape the way an organism might change the way they process information or behave differently. So one of the things we do here is record the activity of an individual neuron in its circuit within the brain.
So you use the word circuit or circuits.
Yeah.
What is that?
So the brain's wired a lot like a circuit board on a computer or the circuit that runs power to your house. Really the heart of what we're trying to do here is identify those very specific changes at either an individual neuron level or in a circuit level. One of the main areas that we're working in is in this area of autism spectrum disorder.
Right.
So again, we have an animal that's missing one of these key genes that we know when it's missing in people, those people very often, at least 80% of the time, get diagnosed with autism.
Or the circuits that malfunction or whatever, are they fixable?
That's the hope. Really the meat of what we do is to then dive into the brain and look for these very specific changes in neuronal activity and how neurons change the way that they're communicating with each other. Because if we can, then we can identify a very specific molecular change that's potentially druggable. So this is actually a cell of an animal that has a genetic manipulation. We take that tissue sample and we put it here in this well plate right here.
What we're looking at is a healthy cell.
Yeah.
And it's performing the way it's supposed to. Is that the third grade version of this?
It's pretty accurate.
Well, hey, third grade, I got it. Why are we doing this?
These types of neurons transition from behaving very regularly to very irregularly. And this is something that Ikra Ahmed, so she's also a second year graduate student in our program, has been working on. And so she's looking at pattern expression in very specific brain circuits as well.
So we are actually trying to identify that if these molecular patterns are different in stress mice compared to the ones that are non-stressed.
And as Ikra said, what we're trying to do here is see if there's a pattern change in what an individual neuron might express or might have present inside of it that would correspond to some of the changes we see using that functional assessment.
What are you in hopes of trying to solve?
So in an ideal world, we're able to come up with new treatments, new avenues for treatments for diseases like autism spectrum disorder, ADHD, anything related to negative outcomes that occur in response to early life stress.
Ben, thank you so much.
It was great to have you.
We appreciate it. Hope everybody learned something today, and back to you in the studio, Anna.
Thanks, Jeff. What a fantastic and very educational visit to Springfield. We're so impressed by the work the SIU School of Medicine is involved in. Learn more about the school by heading over to siumed.edu.